University, whichever way around it is. It's a Russell Group. It's a red brick university. If you manage to get in there and do an engineering, and I think what they require, it's right in front of me here. So if I were to look for, let's say, in aerospace engineering, they require AAB, but they will be flexible in that. And if you are doing, or if you have done BTech, that can easily be translated to that AAB or ABB. So my message to students is this, that whether you are in the final stages of your GCSEs or got one more year to go, you have A-level results now, or you're waiting for BTech, you should pursue your career in what you enjoy the most, in the subject area that you enjoy the most. I enjoyed engineering. I loved it. I loved BTech National Diploma. Even at lunchtime, I used to go and read automotive books. Now, I didn't like electrical electronics. I passed through that. But you're not meant to love all the subjects. When you're in school or college, you are not meant to be good at all the subjects. So a lot of students and perhaps parents might think, why did my child get low mark in, let's say, geography? A student is not built to understand and be good in all the subjects. There are very few students who are very good in all the subjects. That's very few. It's just the way the mindset is done. But by and large, if you are more strong towards engineering subjects in school and college, towards physics, maths, computer-aided design, product design, industrial design, is very likely you should pursue towards STEM subjects. So that's science, technology, engineering, and maths. Okay, they go in hand to hand together. There is a bit of a rift between science and technology, but it's always going hand to hand together. Anyhow, so after completing my BTech National Diploma, I had choice. In those days, there were 9 institutes that we had to choose. I think nowadays it's only 5. And I chose 9 institutes around the country, and I went to every single one of them for the open day, except Newcastle Polytechnic. We had Polytechnic in those days as well. And the reason why I didn't go to Polytechnic, because on the same day, it was Newcastle University. So out of 9, I went to 8 institutes. And it is very important for you guys, even for the parents, to go and visit these institutes that your child is going to go. So you can talk to the module conveners, teachers, lecturers, go and have a look at the classroom. Their facilities is it's paramount at this point. And I am with the University of Leicester. If with Dr. Tariq, we can perhaps arrange an open day early next year, you can come and visit us at the University of Leicester. So it's important which institute you end up in. Mainly for undergraduates, it matters. So when you do your undergraduate degree, it matters which institute you do it at. When you do your PhD, it matters who your supervisor is. Okay, it's the other way around. So if you have an option to go Manchester University, do so. And the next best one in Northwest, I would say, is probably Liverpool University. There's about 2 or 3 in Liverpool itself. So Liverpool, John Moore, of course, MMU is there, Salford, Bolton, Lancaster, UCLan. But my advice to you is that if you are able to secure a place at a Russell Group, Red Brick University, especially if it's in top 20, that will do you a lot of good. Now, obviously, these places and these universities come in high demand in terms of how many students they will have. Manchester University is huge. I think they have 35,000, 40,000 students on and off campus. So sometimes being a huge university has its disadvantages as well. Now, I'm not promoting University of Leicester, but our university, we have 600 engineers. So very small in comparison to University of Manchester, but we emphasize more on quality rather than quantity. So I came from a university prior to University of Leicester, from Hertfordshire, down south near London. And they wanted to get more and more numbers in. And the students in engineering were 2,000 because more students means more revenue. So the emphasis was more on quantity rather than quality. Now, to get into STEM, you would need, I mean, okay, just to finish off, I was at the University of Nottingham. So I did MDMM. It was a relatively new course, which means BEng, Bachelor of Engineering in Mechanical Design, Materials, and Manufacturing. And the reason why I did materials design and manufacturing is that I didn't like pure mechanics. Now, some of you in school and colleges, when you come to do pure mathematics, pure physics, I never liked thermodynamics. There's too much calculation. It's very complex. So I did a bit of all three. A bit of mechanics, there's mechanical design, there's elements there, there's forces that you have to calculate, there's bridges, how many cars can go at any one time, so on and so forth. And materials, what is the best materials for aeroplane, for example? Now, aeroplanes by and large are made from aluminium. Why not steel? Steel is stronger, but steel is heavier. So these are things that you learn in university. And then it's manufacturing. What's the best and most efficient way to manufacturing a product or a component? Yeah. So that is the degree I did, and I loved it ever since. And then I joined an automotive company, or rather a company which served automotive company. So I am an automotive engineer by trade. I spent 8 years in automotive engineering. I also had a couple of years of my business experience, which, well, I didn't make millions, because if I had made millions, I probably would not be sitting here in front of you guys, maybe on an island somewhere. So then I did my PhD in renewable and smart materials. And Alhamdulillah, for the last 10 years, I'm in the teaching academia. And I have seen students and I have taught many students. I have interviewed many students and I have been on panels many times. And in order to get into STEM, and I will address some of the questions that will come later, but effectively for you guys, for students in GCSEs or finishing college or in the first year or just finished the college, and to parents, my advice is this. Whatever area of expertise in engineering that you would like to pursue your career, do so and excel in that area. Let me just quickly share you this screen here. And I'll put this on, I'll give it to Dr. Tariq and put it on here, and I'm sure he can advertise this. And this is for download. It's a free brochure here. These are just some of the occupational some of the occupation group in STEM. So if I were to, I don't know if I can. Okay. So if you look here on the top, management, you got computer and mathematics, architecture and engineering. Underneath that, you got the aerospace, agricultural, biomedical, and within biomedical, there's so many other branches. So you need, and with biomedical engineering, you would work with somebody like Dr. Tariq, probably those who are from medicine as well. So civil engineers would work with scientists and general engineers. So as an engineer, you will never work alone. You will always work in small groups or in teams. It's always a team-based work with engineers. So this is just a snapshot view of what the occupation are in STEM. And I also want to say this, that I have seen more and more female coming into STEM now for the last few years. STEM was mainly dominated by male students, but I have started seeing a lot more female coming in, and more encouragingly, mashallah, I have seen a lot of Asians and a lot of Muslim Asians coming into STEM, both male and female. And we need that. We need that, as Dr. Tariq was saying, how to promote yourself, or rather work your way up into the community, be an excellent engineer, an ambassador. So it's very encouraging to see a lot of Asians, and in fact, our University of Leicester, our vice chancellor, is from Sri Lanka. So he's an Asian. So one of the 6 BAME vice chancellor in this country, and there are about 140 institutes. So he's promoting even more. And we are the first university. We said, our vice chancellor said that he will honor the mock A-level exam results, not the one that's been downgraded and recalculated, because as we know, A-level grades have been downgraded and a lot of students are not happy. So he was the first one to say, we will honor the mock results. So that is very, very encouraging. And then when you just have a read at this, when you this goes to show in the occupation, which is a very fast-moving employment growth, which is projected 2012 to 2022. I don't know if you can read, but right on the top, information security analysis, projected 102,000. Operation research analysis, statisticians, biomedical engineers, actuarials. So STEM is a very, very important component. I mean, in India, engineers have before doctors. if you have a look, that's how it's been promoted. Unfortunately, not so much in this country. It's how it's been promoted as well. Engineers always comes, or they emphasize more initially or first in India, even before medical doctors. But in this country, of course, we have medicine, and a lot of students and parents, there is that monetary aspects of it as well. But then again, if you go down the route of data mining, cybersecurity, AI, coding, if you want to make money, there's a lot of money to be made there as well. Okay. And just to finally, yeah, just to finally to wrap up my presentation, or just a talk. Just a second. Sorry, I'm not all that good at the technology either. But just to wrap up, my advice to the students would be that pursue a career which is dictated by the subject that you enjoy at school and college. So if you enjoy mathematics, physics, computer design, you are in very good position to go in towards engineering. Now, again, in engineering, it's a huge minefield. So if you enjoy automotive, there's aerospace, there is satellite now, there is general engineering, there is civil, chemical. There are dozens of degree programs that you can affiliate yourself with, but do not look at the money and do not put money first here. You should enjoy the subjects and you will enjoy the 3-4 years degree even more so. And I also would like to say this, that I personally did not do industrial placement. So the degree is 3 years. With industrial placement is 4 years. Again, things were different in 90s for us. Excuse me. And I advise all my students who come in the first year of undergraduate is that please do an industrial placement. That adds 1 year to your degree program, but that brings huge benefit to you. And 3 benefits I can quote right now. One of them is that you learn money. When you go into an industry for 1 year, they'll give you minimum wage, whatever, 18,000, 19,000 pounds at the moment it is. So there's monetary incentive there, which will help you pay for your final year tuitions and your fees as well. Secondly, it's most importantly, it's the work experience. When you are in an industry, I go and visit a lot of my students in industry. I've just been to McLaren just recently down south. It's like an art gallery. The McLaren shop floor is like an art gallery. That's how beautiful it is. And then you get to move into different departments in manufacturing, in design, in HR, in management, in sales. So you get to learn different disciplines. So you get monetary benefit, there's experience, and when you come back for your final year, you have to do a 3 months of final year project, which you can do based on that industry, which means it'll be easier. And fourthly, is that it's quite likely that you might be offered a position at that company. And I have many examples. I have students from India, Pakistan, who did industrial placement, and they're working at Bentley and Rolls-Royce because of that 1 year that they spent in the industry. So again, please opt for industrial placement. And there are, of course, I think 1 year industrial placement, and there is, I think you can go to another country to do more modules. But for me, that's not. I wouldn't go down that route. I would go and stay in this country, do an industrial placement in an engineering firm, which will give you a flavor of what engineers do. Will give you a lot of experience, and when you come back in the final year, you will be a different person altogether. So I think I'll stop there. I'm not sure how long I've gone on for, but if you have any questions for me, please do type, and you may reserve them towards the end. Thank you very much.
Acha.
I'm willing to take some questions on that if somebody has any.
Maybe we can reserve the questions to the end.
Okay, all right.
And you can end the sharing of your screen, please. Can you?
Stop share. Yes.
Yes.
Okay.
Dr. Tariq, your mic is muted.
Okay, can we ask Ali Javed to start his presentation, and you can start sharing the slides?
Okay, so I'm going to I'm going to start sharing my screen now. Just
Thank you.
a second. So can you all please confirm that you can see my screen? Is that okay?
Yeah, we can.
Yeah, fantastic. So Bismillahirrahmanirrahim. So carrying on further from Dr. Patel's presentation and very useful knowledge he actually shared with amongst us as well. So just to have an understanding of what a STEM subject or how STEM sector looks like, I think it's prudent to have a look into the background of that. So basically, the way how we see things happening in the world now within the STEM sector, they have never been like that. And all of these things, they have evolved in the as a result of industrial revolutions. And quite luckily, we are in a place where the global industrial revolutions actually took place. They took place all starting from the very first industrial revolution to the second, third, and the current transitional phase which we are now. So just to give a little background about myself, so as you all know, my name is Ali Javed. I work for an organization called Wood PLC. So that's a multinational company, used to be called as Amak Foster Wheeler. And we are present in 65 countries of the world, employing about 7,000 employees worldwide. So I am I'm a technical lead in the environmental infrastructure division, which mostly looks into these things like renewable energy, waste management, and all the engineering side of these things as well. In addition to that, I'm also part of an organization called Muslim Engineers Network. We have been, it's a UK organization. We have been around since 2008. So we are over a decade old now. We have about 1,600 members in the country. Until July this year, I used to head the Northwest UK sector of the Muslim Engineers Network. But again, thing is that Muslim Engineers Network, like any other professional organization, we are multidisciplinary professionals. Either we are in the process engineering, mechanical, civil, electrical, control instrumentation, aeronautical, material sciences, computing, and R&D as well. And we come from all sectors of the industries, which including oil and gas, aerospace, power generation, renewables, telecommunications, construction, water, railways, academia, and a lot more. What we do as an organization? So what we do, I think there is some problem with the voice. My voice is echoing.
Are there two devices nearby, very close to each other? That could be one reason.
So I'm not sure about. Okay.
Yeah, it could be the bandwidth, internet bandwidth. There isn't much we can do.
Maybe. Okay, so I'll just carry on with this one as well. So what we like to do as an organization is that amongst our members, we have got senior industry professionals. We share all sorts of job openings, have got a very strong team, carry out advice on CV development, mentoring about how to pursue in which sector of STEM to pursue. We organize different events, for example, workshops. We do online webinars, seminars, and we also organize our annual networking events, so which happen in our three different local sectors within the local geographical locations within the UK. We also provide support to local colleges and schools as well. We work with them and provide them support and mentoring on the STEM subjects. And we also liaise with the Islamic societies so that those students who are on route to become engineers or STEM professionals, they can also avail our support on different future prospects as well. So talking about the Industrial Revolution as well. So basically, where did the Industrial Revolution begin? So the first one began in 1760, followed by the second one, which was a transitional phase from the first to second one, and then 40, followed by the third one, which officially began in 1969. And now, as per some experts, we are already into the Industrial Revolution 4, or the others say that it's still a transitional phase between it's a still third Industrial Revolution. We are into a transitional phase, which is the automation phase of third Industrial Revolution. So, for example, I know how many of you have seen these running live? So none of us. And so believe me, I mean, the thing is that these were the first ones which came out as a result of industrial revolution within this country, within UK. It started in 1760. So before that, these railway carriages, they were pulled by the horses. So, and the thing is that they were less effective. They could carry less load. They could cover less journey. And the thing is that the amount of the turnaround time or different activities which could be carried out for industrial development was incredibly slow. Things were produced with the hand, and again, since the quality of life of the common people, it was increasing, it was improving, and their demands were also increasing on the same hand as well. So the hand production rates were so slow, and within this first industrial revolution, we saw things which moved from hand manufacturing to machine manufacturing. There was also a development of machine tools as well. So initially they were all carried out manually by men or women, by special craftsmen. They were replaced primarily by the machine tools as well. Then there were mechanized factory systems as well, whereas initially they were all secluded in small places as well with very limited production capacity. So things became more centralized, and then we had our mechanized factory systems which were able to produce a lot more in bulk quantities from one single place. So textile manufacturing, chemicals manufacturing, and iron production was the core developments which were obtained following the Industrial Revolution 1. Again, in addition to that one, there was also water and steam power, which resulted in the development of different locomotives as well. So which provided massive boost to the rapid transaction of things happening across the country. So when we talk about different highlights of the Industrial Revolution 1, so what actually was obtained, which sectors got boosted during as a result of Industrial Revolution 1? Cement manufacturing. So basically before the Industrial Revolution, there was very limited production of unformulated cement manufacturing. People didn't know what cement is, what it can be used for. These days, everybody knows what cement is used for. It's the most important ingredient within the construction industry all across the globe. On those times, nobody knew what to do with that. This thing was actually mechanized, transformed from hand development into the machine output as well. Cement manufacturing was carried out under a specialist formula. And the thing is that depending upon the requirement, those formulas were modified to provide a product which suited the requirements. Not at a great extent, but yes, it offered a lot of flexibility compared to the past. Gas lighting. So natural gas reserves were found out. There wasn't any concept of street lighting, or prior to that, the street lighting was carried out by kerosene oil lamps, which was again, okay, it helped a little bit, but the thing is that it then needed to be topped up. They were not very bright. They had to be replaced by someone. So gas lighting was actually a source of continuous lighting at a better rate, so which involved less human interfacing as well. Glass making, prior to that, glass making was not an industry, very rarely used. People were used to wooden or similar sort of cutlery or other utensils as well. People moved on to glass making, paper machinery as well. So again, such a blessing that in the past people used to write down on tree skins or leaves. So paper machine was another blessing as well, that using the same raw material from tree skins and their residues, paper actually was manufactured, which could be used. So it was like a lot clear and refined product compared to the ones which were used previously. Agricultural modifications were carried out. So agriculture was never like the way it is now, or even before the industrial revolution as well, during the first industrial revolution as well. Agriculture was a very slow process, very, very labor intensive. And the thing is that depending upon the climatic conditions, there used to be hardly 2 or at the maximum 3 crop per year, which was insufficient to fulfill the needs. Mining, again, revolution also included improvements to the mining industry as well. It became an industry. People started using machine tools for mining. Prior to that, they were like very rough measures taken out, lots of fatalities in mining as well before the industrial revolution. So it started improving as well. Transportation, so again with the development of steam generation systems as well, quicker locomotives were developed, replacing animals, horses and bull carts and things like that, and they were able to carry more weight, and they utilized less energy, and they were able to carry out any transition for longer distances comparatively. And then the canals and waterways constructed as well. So in UK, I mean, I'm sure everybody has seen those vast network of canal and waterways as well. They were all result of the first industrial revolution. And then roads as well. So basically prior to that, they were only not a very mechanized network of roads as well. They were all improved as a result of the first industrial revolution. Along with every industrial revolution, we also need to know, and we all have to understand, that there are massive social impacts as well. So prior to the industrial revolution, there was the entire industry of the world was mainly comprising of agricultural industry or agricultural outputs. It shifted from agriculture to factory working. The novel skills were created. People got used to or they got known to new technologies or new skills which could be used within the factory working. Better goods productivity as well. So obviously something which can be produced in-house was a lot less compared to product produced in the factory, larger scale as well. Higher manpower utilization as well. Again, a centralized facility allowed a higher manpower utilization as compared to the segregated places with only a handful of people working over there. A very important aspect of that, a stronger middle class of the society was developed with this one. So prior to that, there were two main aspects of the society, which was like the owners and the workers, and very weak middle class of society as well. So industrial revolution also helped to develop a very strong middle class society as well. So they were paid laborers or technicians, factory workers as well. They earned more than the normal workers, but less than the owners as well. However, that exposed them to a better quality of life, and which actually resulted in the evolution of a stronger middle class. However, with that one, health and safety was again became prime importance because because of the rapid uh, mechanization or industrialization as well. Health and safety and environmental nuisance became more of an issue as well. Whereas the small places, they were not as bad compared to the largest places as well. And again, so first industrial evolution covered a gap which was from slow productivity to a faster productivity. However, the it also identified gaps which were related to the health and safety and environmental nuisance as well, which were again covered in this in second industrial revolution as well. So what was the second industrial revolution? It didn't happen on its own. So basically, it's a continuation of the industrial revolution one development. So things already had developed. However, there were massive gaps found in there as well. So people, so within the industrial evolution too, for example, when the steam engines were developed, people found out that they need to have a better infrastructure of railroads. Otherwise, the extent or limitation was quite high, and the extent of their effect was very limited. So they had to build out railroads. To build out of railroads, they had to improve or expand the iron and steel production as well. So for example, whereas there was only a single or maybe less than 5 types of iron were produced, they had to enhance the types of iron productivity which could be used all across the board to suit the requirements. So the use of machinery in a different manufacturing as well, that was also one of the greatest achievements within the industrial revolution too as well. So people from small and manufacturing units, people moved on to the bigger ones. Telecommunication as well, or communication. So before that, they were used to be letters only, delivered by the postman, and then the telegraph lines were installed all across the country, and people actually started sending small scale messages which could be delivered to the recipients straight away, rather than waiting for several days or weeks or even months to reach the recipients as well. And then petroleum development, uh, the natural resources were found out as well, and then there were electrification as well, which again used petrol. So the energy produced from uh, petroleum inputs, they were used to electrify or produce electrical energy as well. So with the industrial evolution too as well, there were again a transition of the social impacts as well that required modern business management. Things were expanding. People were less capable of controlling those expansion and the subsequent business management systems as well. So instead of, so that actually introduced a whole new sector, which was called business management, which we all know that at the moment, all of the organizations, wherever we go, they always have a business management unit within them as well. Rapid productivity as well. So to fulfill the requirements, to fulfill the needs, the productivity had to be brisk. Rapid measures were taken out towards them, and the expansion of industrialization carried out. Rapid transportation as well. So initial engines, steam engines, were not as efficient, and then work was carried out to develop faster, more robust, and reliable steam engines as well. Better public health as well. So of course, with all of these environmental nuisance and people getting exposed to the risks within this factory working environments as well, better public health was needed as well. And again, it also had impacts uh, on the medical services as well. Quick communication. So again, when we talk about these uh, the telegraph lines as well, so things actually went further ahead as well. We had higher food crop yields as well. We had rapid urbanization as well. So people started, so industrial towns were created. People moved from villages to the towns which were created around the industries as well. So which caused urban rapid migration of people from uh, low-lying areas to better developed urban areas as well, which again had their own issues as well. And again, with the rapid urbanization, they were all environmental sorts of environmental nuisance as well. When we again in addition to uh, the difference between the Industrial Revolution 1 and the Industrial Revolution 2 was the key things which could be categorized, which were not achieved within the Industrial Revolution 1, was the development of chemicals through factory production lines, synthetic fertilizers as well. That was one of the key ones as well. Prior to that, they were only used to use organic fertilizers, which were good. However, they were very, very low in productivity as well. So hence, the overall crop production could not be improved because that maritime technology was improved significantly. So that's one of another thing as well. And then from people started developing smaller automobile engines. So for example, uh, having a steam engine within the household was impossible. It was so big, heavy, very difficult to maintain. So smaller engines for automobiles and turbines for electricity production or power generation were also used. So these were the 3-4 key results of the Industrial Revolution 2, which were not achieved within the Industrial Revolution 1. So we now come to the Industrial Revolution 3. Again, with the Industrial Revolution 3, all of the things which we see now, so basically they are all result of the Industrial Revolution 3. However, the way things look like now, they never looked like the same at the beginning of this Industrial Revolution. So the Industrial Revolution 3 is also called as the digital revolution, digital technology revolution. So within the Industrial Revolution 1 and 2, the machines were manufactured, the factories were manufactured. However, they relied mainly upon human interface. Manual interface, human were running the most of the times. So for example, one machine might require maybe 10 or 20, depending upon the size and the complexity of the processes as well. So and then again, it was also causing lots of damage to the public health as well. And the utilization of that manpower could be used on other useful venues as well, rather than just to run the machinery as well. So that actually generated the idea of digitalization of technology, whereas the most of the roles which were, or minor roles which were offered by human beings, they could be replaced by actually adding some digital mechanism to the machinery so that they can replace the role of human beings. So thereas we came to the idea of these controllers, buttons, start, stop kind of things, speed control, up, down, medium, controlling of the different productivity as well. We came to the idea of rollers, presses, and things like that, where their speed can be controlled, their productivity can be controlled, which were only controlled by humans during the Industrial Revolution 1 and 2. And then developing from there as well, that the digital technology revolution had again incorporated massive control units as well. And again, that was quite energy intensive, quite space intensive as well. And then they subsequently the maintenance required in them was quite extensive as well. So that gave rise to the idea that, okay, these need to be, the size need to be reduced down. They need to be less energy intensive. They need to be they need to be a lot cost effective as well. So, which actually gave idea to the development of computers and the communication technologies as well, so that the computers would be developed, they would communicate with these machineries and other mechanical equipment or electrical equipment as well, so that the sizing of that becomes smaller and effective communication can take place. So that was actually the basic idea behind the development of computing and communication technology. However, this was not achieved until the transistor was developed. So basically, a transistor is the one which actually converts digital signals to the recipients, to where it's used to be controlled. So that was actually developed in 1969 or 1959, I guess. So so basic revolution within the Industrial Revolution 3 was actually achieved by the development of transistor, which enabled massive reduction in the sizing of different mechanical equipment or electrical equipment or all the ancillaries as well. Instead of having massive units, it was replaced by a small unit, and then the further development of transistors into silica-based transistors as well further enhanced the sizing reduction of these transistors as well. So, so basically all we see these days, all of these ICs, circuit boards, connectors, so they're all developed from this transistor. So basically a transistor became a blessing for the whole mankind that massively improved the communications capabilities across the globe, and it also massively reduced the sizing, and it opened a complete new era of development within the digital technology. So with the development of transistors as well, computers which were used to be only meant for industrial applications, then they became a household commodity. In the 80s, late 80s, early 80s as well, house computers started to be used as household commodities as well. People started using them as their for their daily needs as well. So a small calculator or even video game. I mean, they're all a form of computers in a shape. So it has never been like a mouse or a keyboard and a monitor in the beginning. So it was like a very small device which could only give like one or two outputs only. But that was again a part of computer as well, and again a part of the evolutionary process as well. Then with the development of home computers as well, it came down to the communications technology as well. And the initial computers, they were not capable of handling larger packets of data transferring as well. So for example, any bigger email or an attachment to an email, to send that across to a different recipient was a massive difficult. So still people were using older techniques, for example, fax machines or postage of or posting of the of drawings, etc., through traditional measures as well. So this is where the evolution or the development of World Wide Web was carried out, which we commonly refer to as World WWW, and you can see that it's prefix to all of the names of the websites and domains and etc. So it's basically uh, it splits the bigger packets of data into a bigger packet of data into small packets of data, and it's used in all sorts of transmission of uh, information across different recipients as well, and then which again carried out the development in the rise of digital technology as well, which is kind of non-stop evolution and still happening at the moment. So rise in digital technology, when we talk about those, then the rise in digital technology, we're talking about the development of telephones. From telephones, we are talking about development into the mobile phones, all the ancillaries which are, so the telephones were all connected via wiring system. They were connected to the main servers, main exchanges, and then to the poles, whereas the mobile phone systems, they were all connected wirelessly. You charge a phone that will connect to the main servers uh, via equally distant located boosters at different places as well. So they would transmit electrical signals to the main servers, and hence people were able to communicate with them. Another rise in, and then again, the sizing of, so on the parallel sides as well, uh, the transistor development or the chipboard development was also carried out, whereas there used to be big size chipboards as well. They became smaller and smaller and smaller. The hardware became small. So whereas in the late 80s, phones used to be massive, they weighed a few kilograms. Now we have come to a point that we have got phones which only weighed a few grams, and we can see a lot more. It's like a complete computing system within a small phone as well. It takes talk about cameras in the beginning as well. They used to be massive, all manual analog cameras, or even manual cameras as well, with 36 or 22 millimeter uh, photos slides going in there as well. Now they were replaced by the digital cameras, and then their pixels are improving as well. We're talking about televisions as well. We used to have old, big, massive. They used to weigh like several kilograms, massive televisions. And looking at the evolution, they moved into the plasma, from plasma into the LCD, now LEDs, and then we are talking about now we have gone into 4K or even 6K, uh, very high definition LEDs as well. So in a nutshell, I mean, the thing is that all of these things, they were developed they were produced as a part of industrial revolution, and a continuous development has been carried out, and the rise of digital technology has actually been carried out with the research and development, which means that the life of ordinary human beings, they have improved significantly with the result of these industrial revolutions, and it's still evolving at the moment. And then we it was only realized in 2015, basically, when within the Global Economic Forum, it was revealed that actually we are into Industrial Revolution 4. So what is Industrial Revolution 4? And this is where we live now. Current era is of the Industrial Revolution 4, is actually the automation of industrial practices. So the Industrial Revolution began with the development of factories, small scale factories, all controlled manually, all manufactured manually. Then the Industrial Revolution 2 became resulted in the expansion of those facilities as well, still managed by human beings, manual interfaces as well, manual intervention as well, energy intensive, uh, manpower intensive, all sorts of these things. And then the digitalization as well, which means that there was a reduction in the human interface, and it was replaced by the local controllers as well. Size, the mechanical equipment size was reduced as well, and then it's continued to reduce down significantly as well. However, there was still, so for example, I mean, if the 80% of the manpower required to run a machinery was replaced by these controllers as during the Industrial Revolution 3, it was later found out that with the development of these automation technologies within the computer and IT sector, these had consequences on all of the other industries as well, and which also raised to the fact that why can't these industries be run completely human interface free? So the concept of robots came in that era as well. You see lots of these industries, they have got fully automated. They are run by robots as well, especially the automotive industry as well. You look at them, they've got robot lines, and they produce complete automotive from start to end, all done by robots as well. So what happens that behind a robot, so robot is again another mechanical machine as well. It's a mechanical equipment. It has got chips connected to them as well, and then they interface with the control mechanism, which is usually a computer. A computer has got a program stored in it as well, a complete program written in a specific computing language as well, that identifies the controlling of that robot, and once it's implemented, then the robot actually follows the patterns which are developed as language within the computer. So this is how it happens. And that was actually the beginning of the Industrial Revolution 4, and things didn't stop over there as well. So interconnection, which I've already explained as well, became the information transparency became quite obvious as well. Things became a lot more clear, a lot more robustness was carried out, and a lot more technical assistance was possible with the development of these automation systems as well. So whereas in the past it was carried out by the human interface as well, now we have got decentralized decisions as well, which means that the more than one inputs can be carried out. So for example, I can be in the UK, and my colleague can be in the United States, or another one can be in the Japan, and or even any remote part of the world as well. All they have to do is they have got a mobile phone in their hand which has got data enabled. They connect their phone with their laptop or their tablet, and we can all communicate via the way we are communicating today. It's on online communication portal, and they come down to a decentralized decision, or they provide an input as a language, electronic language input to a device which is operating in another part of the world as well. So this is how things have evolved significantly. We have come into the concepts of smart factories as well, whereas I mentioned earlier on as well, so for specifics for the example of automotive industry or aircraft manufacturing industries as well, and again a lot more industries as well, where a computer program is incorporated or embedded into a robot's mechanism, and then that robot actually carries out the entire duty as per the instructions given, electronic instructions given by the software which is stored within its chip. And it's not a big equipment. It's just a small chip which is connected into one part of the robot, and it does all the job. And the only human interface remains in that case is the upgradation or carrying out technical due diligence or kind of things as well. This thing also evolved the artificial intelligence concept within the entire industry as well. Whereas, so say for example, we need 5 or 6 people actually use their brains to develop an idea or to pass that communication. Whereas in this one, the softwares, there have been several languages which have been developed, which actually can reflect the way how a human brain works, or it can work. So the way how human beings, they look at different examples and they deliver, and they change their mind accordingly, according to the evolving situation as well. In the same way, this can be embedded into into a machine via a software language. It enables the machine via that software to analyze things, to monitor the patterns, the way how things have been working, and it can predict the way how things are likely to happen. So for example, a control system within the operations of a power generation plant actually. So there are lots of inputs into one single unit as well. So with there are several outputs from the power plant. So for example, the overall power output is going up or down. So just to maintain that will provide, the main reactor will provide signals to the feed input as well. So in the event of going above its capacity, it will provide signal to the feedstock input that will reduce the quantities of the feedstock. So it will come down to its normal design phase, or in the event it's going under production, it ramps up the feedstock production and it goes up. So it's like we are talking about artificial intelligence. We are talking about smart cars now. We are talking about driverless cars now. Uh, we are talking about self-assisted cars as well. So, for example, auto reversing, auto adjustment of the cars as well. So there are hundreds of millions of examples which can be given now. However, the thing is that so these are all form of smart sensors as well. So basically, I just came up. So smart. So basically, a unit is is fitted with plenty of smart sensors designed by a human, and then it connects to the main interface as well, which receives instructions from there as well, which enables them to analyze and execute the actions by themselves as well. So as essentially eliminating all of those human interfaces. It has been successful in lots of industries, yet to be successful in the rest as well. So it comes down to the point that whatever industries we look at, this digital automation has become part and parcel of that. It is very, very prominent, can be seen everywhere as well. So with the perspective of an engineer, I'm of that opinion that it doesn't mean that our career path is pursued in IT only. IT is part and parcel of all of the industries at the moment. So our learning, IT-based learning in these sectors, in STEM sectors especially, is pivotal now. So it will be prudent to follow a STEM profession which has got these IT modules embedded into them. Because the thing is that allows twofold benefits into them. Basically, it gives you experience or exposure to more than one skill set. So for example, you are engineer and you are, so if I'm talking about an engineer, if you are engineer and an expert in the relevant software sectors of that engineering field as well. So that enables you to become a specialist in one sector. So, and again, when you progress, when a specialist progresses further up in his career path as well, that that skill becomes strengthened, and it's a higher opportunity that you can become a leader of that specific skill set as well, specific sector as well. So again, we're talking about the social impacts with these Industrial Revolution 4 as well. Things have all digitized. We all carry mobile phones with us. They are full of games, social medias. I mean, you don't even have to pay. You don't even have to pay calling abroad. I still remember uh, not long ago, maybe back in 2004, 2005. Uh, Calling abroad was extremely expensive. I still remember calling back Pakistan in those times. Only for £5, we could only call for like 10 or 15 minutes. So look at now. I mean, one small application called WhatsApp, we can call everywhere. We can talk to them live. We can send message. We can send lots of packets of data, attachments, very easily without spending any money. It's all come down to the expense of having of spending some data allowance from the mobile phones. Automation has become very reliable. It has become very strong. It's part of every industry now, and this is something which is still evolving, and it seems like that it's a never ending evolution. So pretty much Industry Revolution 4 is carried for a few decades. As human machine interface has pretty much diminished, is gone to very low levels as well, and then humans are more involved in the development of those interfaces rather than actually controlling the machines as well. Uh, Equipment has social media, again, very quick communication. Something happens in farthest corner of the world is spread across the globe within less than few minutes. It's so fast. Equipment compaction as well. Again, a handheld mobile phone is the best way of communicating everywhere in the world. You don't need to carry big laptops or big screens or monitors as well. They do all the job for you. A mobile phone does all the job for you as well. Social improvements as well. It's again, you are closely connected with your friends, colleagues, other subcontractors for your work purposes, for your social purposes. You're always connected. You are never out of connection. And environmental nuisance, yes, there are significant environmental nuisances as well. Things are going from 4G to 5G now. We don't know what's happening with them. Just have been such a rapid evolution in these ones as well, uh, that we don't know the environmental consequences of these evolutions yet, because it only happened in the last 2.5 or 3 decades as well. So that's the biggest unknown at the moment as well. People are still trying to understand that. They're gradually evolving. However, the thing is that the evolution of the corresponding environmental nuisance, the knowledge about them is a lot slow compared to the actual evolution of these technologies under the Industrial Revolution 4. Last but not the least, I'm always of this opinion that I've talked about in my summary, in my presentation, I've talked about the last 300-400 years of evolution as well. I'm a lot mindful of the fact that what is the participation of Muslims within that. As a younger generation, I would emphasize on this one as well, that this is something which is a massive gap. Either So it doesn't mean that we don't have any participation, Islamic participation in there as well. But the thing is that that needs to be centralized, and that needs to be delivered via a streamlined platform as well, so that it doesn't get lost under, which is happening now and which has been happening for several centuries as well, that it is getting lost under or snowed under others. So be mindful of this thing as well. So we need to have these streamlined platforms as well. IT or these things is the future of every industry. But the thing is that IT skills must not be, in my opinion, IT skills must not be obtained at the expense of other industries as well. Other industries needs lots of specialists as well. For example, a nuclear industry, which is very clean mode of power generation or energy generation for the future. There are very few uh, specialists in this country, and has been a massive gap in this one as well. So please be mindful of the fact that you want to become an expert, but you want to become an expert in a sector which is a STEM sector and supported or powered by IT. So don't, it's not and in this particular matter as well, in my opinion, you can ride two boats at the same time. So that's all from me. So Jazakallah khair. Thanks very much indeed for being listening to my presentation. So brother uh, so I can actually finish mine now, and happy to answer any questions which have been arising over here as well.
Okay, thank you, Brother Ali, and it's a very wonderful presentation going through all the parameters, and I think we will open it to question answer session now um, to the audience. So I think Imran, you have noticed some questions. So is it possible you could answer some of them?
Yeah, I've already answered few, but then there is, I think, question centers around women. Why are women probably not so much in engineering or in STEM? And I think more to the point, maybe Muslim women are not so much in engineering. I think it goes back to the fact that in the same way that men are not so much in midwifery and nursing, and that number is increasing in the recent years.
Yeah.
Now, a lot of the STEM programs are designed with females in mind. What that means is that over the years I have seen, as an engineer, I used to be an engineer, as I said, from 96 to 2004. Wherever I used to go in engineering firms, mostly it was male engineers in the offices and in the shop floor as technicians. But then over the last 10 years, I have seen a lot of changes in that. I have seen a lot of females coming into shop floor doing manual work, computer work, office work, engineering, management jobs. And then even in my class at universities, there were only maybe a 1 or 2% female representative in the undergraduate courses. Now, there I would say about 20% are female. And it's also encouraging to see that, you know, mashallah, a lot of Muslim girls are coming into the arena. Because I think the perception is, even with males, is that, what do you think of as an engineer? You probably think as an ironsmith, you know, as an engineer, or probably a mechanic or a roofer, somebody who's working on the road, painting the signs. That is not true. That is absolutely not true. Whatever you see around you in your house, you got the, Brother Ali made a fantastic presentation there about computers, technology. Those are designed and made by engineers. The cars, the planes, the trains, buses, engineers, the roads, the houses, and the bridges that you cross, engineers. So engineers play a fundamental role in a daily life when it comes to design, selecting materials, in manufacturing, in maintaining. So move away from the perception that it's a dirty job, it's demeaning job, it's not paid well, it's labor intensive, and it's male dominated. I think that perception should be removed, and that is not the case. And there are a lot of women who have worked their way up into senior management. Now you have actuarial engineering, for example. So engineering has diversified itself. What does actuarial engineering mean is an engineer who is very good at maths, so statistics, statisticians, and they work with huge banking companies and other investment companies. So never think as engineers as what we used to think probably about 20 years ago. We have diversified a lot. Also, last year I read a UN charter in which the UN predicted or stated that the students who are studying GCSEs, 60% of the jobs are not created yet when they come out after graduation. So if they go into secondary at the age of 12, when they come out at 22, within that 10 years, there will be a lot more jobs, which does not exist at the moment. Okay, and for that, we need obviously both male and female in all the disciplines, in all the industries, and at all different levels. Okay.
So I have, so just to add to this one, please, that with this industrial evolution as well, all of the sectors, I mean, never mind engineering or STEM sectors, all of the other sectors, they have computing and automation systems embedded into them. So which means that if we are talking about medicine or teaching or accounting or law whatsoever, so I highly encourage females, sisters, please do go for these STEM subjects. It's a very noble profession, and don't hesitate from going in there as well. So there is no stigma related to this one. This is absolutely brilliant. It gives a lot of flexibility as well. Those who want to work part-time or work from home as well, there are lots of opportunities available in there as well. So please don't be scared. Don't worry about the lower numbers of women and higher numbers of men in there as well. Go for it. Go for the follow Nabi Kareem Sallallahu saying that knowledge, learn the knowledge. Never mind. You'll get the skills, you'll get the expertise, and that will always benefit you. Nevertheless, if it's if it's men or women, go for the knowledge, inshallah.
Is there any other questions from anybody at the moment? There was one question earlier about that whether studying in university and in some of the academic institutes in London, is there any preferable to rest of the areas in the UK?
Yeah, I think I saw that. I think somebody mentioned Imperial. My thought on that is, depending on which institute you do your undergraduate, it matters. So if you are able to get into the top 5, top 10, top 15 institute in the UK, when you go for a job, an employer generally looks for undergraduate degree at a good university. Now, when you do a master's or a PhD, it's more important to have a good supervisor, okay? So if you have the option to go to Warwick, Imperial, Nottingham Uni, Loughborough, University of Leicester, Manchester University, these are fantastic, and that's just to name few. There are fantastic other universities which might not be on your doorstep, which may mean that you may have to live away, but of course that's yours and the family decision. But it would matter because the facilities that Imperial and Warwick and Loughborough, University of Leicester, Manchester would have to completing your degree is second to none in terms of the lab work. So if you're interested in going to aerospace, again, I'm not promoting any university, but like University of Hertfordshire, they were founded, the entire university was founded on aerospace since 1953 or something. So I know, I mean, I was there, they have fantastic facilities in terms of lab work. And that's just one example. I'm not encouraging you, asking you to go there, but also look for your own discipline. If you would like to do chemical engineering or marine engineering, then typically universities which are on the coast will deliver a better program. But also you have to weigh up the option that do you then want to, especially for our female sisters, do you want to live away on your own out there? I mean, it's not just female, for male as well. I think equally important for both now. That do you want to live away? And obviously there's an extra expenses there as well. So there are decisions that for you to make. But yeah, the bottom line is it does make a difference, the institute and the facilities that they have.
The other question is that, is it the civil engineering and the chemical engineering fields are saturated?
No, definitely not. I think you don't find so much chemical engineers in this country. Because when we see chemical engineering, we go, oh, Dubai, Middle East. That is perhaps true in many ways. But the field of chemical engineering, we have fantastic ICI, and there are many blue chip global companies in this country who exercise and who deal in chemical engineering. And when it comes to civil, again, what does civil engineering do? Civil engineering is build houses, commercial, residential, buildings, roads, bridges, towers. And there are many disciplines within civil engineering. So I wouldn't say, I mean, you can become an architect as well. Okay, that's a highly, very competitive area to be in as an architect. But certainly it's not saturated. And in fact, my advice again to you, if you are good at chemistry and if you like chemical aspects of undergraduates or rather GCSEs and A-levels or BTech, go towards that area. You will understand chemistry or chemical engineering a lot better than if you did something else. So don't let your future aspirations, your career, dictate by, for example, money or by your friends or what somebody said. My thinking on this is that your future aspirations, your future career should be dictated by what you enjoy in your school, in your college, and the subjects. Okay, that's what it should be dictated by.
So in addition, sorry, just in addition to this one as well, that for example, I mentioned about the nuclear engineering and the shortage of skills within that particular sector as well. So a chemical engineer, just to remove this misconception about chemical engineers that it's all about chemicals, it's incorrect. The chemical engineer actually, majority of the chemical engineers, they design processes. They design processes which take feedstock and give a product. So, for example, it includes lots of environmental engineering in there as well. It covers nuclear engineering in there as well. So lots of environmental infrastructure engineering also within this is covered under this chemical engineering as well. So I mean, there are lots of subsectors within the chemical engineering. It's not limited to chemical manufacturing only. So definitely there is a requirement of chemical engineers. And again, within the civil engineers as well, there is civil and structural aspect as well. So they both possess more or less similar sort of base degrees as well. And with my industrial experience as well, that there is a massive requirement of structural engineers, structural design engineers in the country as well. So please remove this misconception.
There is another question from Avas Khwaja. Would it better to do a general engineering degree or a more specialized one, which is the most beneficial for a career? Imran, can you answer this one?
Yes, I can. I mean, I've been to India and China on recruitment processes, students recruitment. And this is a question that comes along many times. And what are the prospects of jobs as well? So my take on this is, unless you are passionate about aerospace or automotive, then go and do a degree in aerospace or automotive or Formula One. Now, with Formula One, there's a degree called in Formula One, but then you're restricting yourself as a Formula One engineer only, because there are very few jobs in Formula One, as you can understand. Yeah. If you do a job search on Indeed or any other job website, you will find that automotive have picked up over the last 10 years, but there will be, when I last checked earlier this year, it was about 4,000 jobs in automotive engineering. In aerospace, probably a little bit less. Okay, but in general engineering, there are a lot more jobs. So there are maybe 7, 8, 9, 10. So just giving you my experience again, I did mechanical design, materials and manufacturing, but then I ended up in automotive engineering sector. I could have gone into aerospace as well. I could have gone into general. I can perhaps have gone on to a little bit of chemical and marine as well. So my advice is, if you have an option of aerospace, automotive or general, and unless you're really, really passionate about aerospace, automotive, do that. Otherwise, general engineering would be my selection, because with general engineering, you can go into automotive, you can go into aerospace as well. Yep.
Yeah. The other question from Abdullah is that entry requirements at university, for example, Imperial or University College London, is there any specific requirements for them to go in engineering?
Yeah, that there will always be a requirement for all the universities, but they are flexible. So we have AAB for general engineering. Now, this is the advantage that students have during clearing. So you got to remember that universities do compete with each other. They want to retain quality students. So when a university says we need AAB, for example, for general engineering, and you got AAA, AAA, or you got ABB, yeah, the other way around, you are in your right on the clearing day to phone up number of universities and say, I've got AAA, can I come in your university? Okay. Or if you didn't quite get the grades that you were expecting, like we had this A-levels this year.
This level, yeah.
Yeah. So do not be disheartened, because you have to remember the university are reconfiguring themselves as well. The university knows that the A-level students did not get the A-levels that they were expecting. So the expectation the university had was AAB. Because students got ABB, university will go down as well. And we, University of Leicester, have gone down as well. Okay. So because we know that 250 or 300,000 students, however many there were A-level students, generally the grades have gone down. But if you have a look at the statistics, 3%, this was last week's, 3% students got offered more places in university. In fact, more. So do not think that just because you did not quite get the grades that you were expecting, there will always be universities, especially in STEM. In medicine, there are only few universities in the country who do medicine, whereas with STEM, there are all over the country. Then you can pick and choose. Can I go Cambridge, Oxford, Warwick, Nottingham, Imperial? These are top-ranked universities. And this is an advice to those GCSE students and those who are going to be doing mock exam in A-levels or BTech. Do not underestimate the mock exams, please, because this year's A-levels was based on mock exams. So I know a lot of students might think, you know what, it's only mock exam, and I'm gonna do well in my final year. I'm gonna revise for a month and break all the rules. But as we saw this year, the COVID didn't let that happen. So my advice to, I have a child who's going into GCSE. To anybody, do not underestimate the mock exam, whether it's GCSE or A-levels. And it might only be 20-30% contribution to the final result, but please do not contribute to that. And also, the revision is not 1 week before the exam. Okay, a lot of students see that they'll revise a week before or 2 weeks before. I'll drink a Red Bull and all that thing. But we see out and out, revision starts from the time you start your semester. So today, the semester starts, you've done a lecture, go back to it, come in the evening or on the weekend, go back and revise that lecture and understand what it's saying. And if you don't understand that, go and ask your module convener. There's a lot of information there. So your revision should start from day one effectively.
See, other question for both of you is, I think, is the aero engineering, is it demand is now getting low because of the current COVID-19? Is there any impact on it?
Well, no, to me, I don't think there is, because it will go down to an extent, but then the planes are, a lot of planes are grounded by a lot of big companies. But then at the same time, there will be a lot of people who will want to travel. I mean, we saw in last week, 500,000 people went to Spain and they got blocked there or something. So people still want to go on holidays, people still want to go back home. And I'm just reading this morning, chartered planes, private planes are increasing to over 200%. Booking has gone up in private chartered planes. And that will increase even more because businesses will pay money for their clients to come back and forth. People will come into money. Private charter planes will get cheaper as well. So I don't think aerospace, will go down. It might surge a little bit down, but then, and it happens to all the industries. I mean, it happened to automotive in the late 90s, early 2000. It was really low, but it has picked up again. And this will be the case with all the industries.
And if I add to this one, that rather than going directly for an aerospace engineering, so if somebody does a base degree in mechanical engineering, say for example, or EC&I engineering, then they can opt for further specialization in aerospace sector as well. So there is another route of following passion within the aerospace sector as well, by not limiting yourself to a specific aerospace degree only. So which means that if somebody has got mechanical or EC&I engineering degree as well, they're exposing themselves to more opportunities as compared to having an aerospace degree only, which will expose them to one sector. So keep yourselves open to different opportunities. So plan it carefully, to put it this way.
Yeah. Any questions from anybody else?
Yeah, I think it is, how much does it cost to study engineering? I think they're asking here.
Oh, yes.
Yeah. Well, for national students, it's £9,250. That's the fees for engineering undergraduates everywhere in the UK. For international, it's a lot more. Yeah, can you hear me?
Yeah.
Yeah. Okay.
Yep.
So yeah, it's £9,250 per year. I mean, if you got time, I can run you through the maths and try and save you some money, or probably a lot of parents would be thinking that, they will be out of pocket, or I don't want to get a loan because there's interest in it, halal, haram issues and all that. Yeah. So if I may, I can run a very simple maths for you where you will not be out of pocket after 3-4 years, providing, I mean, this is my advice to oh, please do so. Okay. This is my advice to, write this down if you like, to my kids and the people I meet. So let's say, suppose you finished your college. You finished, let's take it from school time. And you got to go to college, or you're going to go to college for next 2 years. My advice is find a part-time job. Okay. First of all, if you find a part-time job, even 20 hours, I think by law you can work 20 hours a week. If you were to do that, 20 hours a week at, let's say, I don't know, £7 an hour. Yeah. So that works out to be £140 a week. Now, if I times that by 52, that works out £7,280. And that's not including working in summer full-time for 3 months. Okay. So £7,280, you work in the first year of your college, second year of your college. So that works out to be about £15,000 whilst you're at college. So that should pay off. So let's keep it £15,000. That's before going to university. Yep, before going to university is £15,000. Now, the 3 years you are at university, again at 7,000, a modest £7,000, let's just say, times 3 years, that's 21 plus the other 15,000. Okay, just stay with me. Stay with me. It's £36,000. So that's £36,000 you have earned in 5 years of part-time job only. Now, if you were to do industrial placement, that I keep saying, and I said one of the benefits, monetary benefit, you will come off after paying tax about £15,000. So you're looking at about £50,000 in 2 years at college and 4 years at uni. Yeah, so that's 6 years. You are looking at £50,000. Now, the fees that you got to pay at university for 3 years, obviously because you're earning 1 year in this place where you don't pay, is let's say £10,000 because you need some money to go to the gym and buy other things and what have you. It's £30,000. And suppose you lived away. Suppose you lived away to Imperial, or let's not call London. London is more expensive. Let's say your cost is another £6,000-7,000 per year more, but because you're living away. So add to £30,000 another 20,000. So that equals to £50,000. Yeah. So effectively, what you can do if you're smart, and as engineers, work smart, not hard. Okay. What this will do is, by you working part-time, it will ensure that it will strengthen your soft skills. You will know how to take notice and directions from your boss. Now, as students and as kids, we don't always listen to our parents, unfortunately. Okay, some of us don't always do that. This will force you to do that, to keep you a good timekeeper, get to the office or get to the shop or get to the factory, wherever you want to be. If you're going to delivery jobs or whatever it may be, it'll make you a better rounded person. It will improve your soft skills. It will ensure how to earn money, how to spend money. You will save about 50 grand in those 6 years. And when you actually graduate, you will come with zero debt. Okay? Oh. You will come out with zero debt. And in fact, if you study from home, and you don't do you don't travel away from your home, you'll save another 20 grand there. So you can actually make money out of studying. I understand that the entire community or the country or academia will say, tick here will give you 9 grand, tick here will give you another 7 grand, tick here will give you another 5 grand. Yep, the banks will readily give you money. I know that. And that's the way that the finance is set up at universities. But if you're smart, you can make money out of this. Okay, just by working part-time, minimum paid job. I just calculated £7 an hour and 20 hours a week only. Okay, not counting summer work. So you'll be more aware of the hours and the money that comes in. So you won't need to get involved with interest. And there's a lot of parents who are concerned with halal haram, because when you get the loan, you start paying interest from day one. It's not after 3 years. When you get that money from the bank, you actually start paying whatever 34%, whatever it is, or 5%, whatever it is. You start actually paying it from day one. And then when you graduate and when you get a nice job, which pays you 25 grand, your money is going to pay for those loans. Yeah. So next 5 years, as I keep saying, there is what's called the instant gratification and delayed gratification. So when you are at uni, when you're at college, you think, flipping heck, man, I've got my friends and they're driving nice cars, they're driving nice clothes, they're going on holidays. That's fine. Okay, that's called instant gratification. Okay, but with you being at college, at uni, working hard, getting that degree, getting that BSc in STEM, inshallah, that 5 years hard work will give you the next 50 years of easy work. Okay, I mean, look at Dr. Tariq, mashallah. He's sitting in his nice room, all the Islamic book at the back. He's making good money. He's got he's got a lot of confidence. He's got a lot of respect. And my daughter tells me, I mean, as I said, I'm in my late 40s. She says, oh, Dad, your hands are so soft. Because alhamdulillah, I mean, I have worked in many, many places. I started work when I was age 13, making belts that you wear as part-time. And I worked in rack factories, and I worked in newsagents and petrol stations, and I'm McDonald's. So I work every year. So I appreciate money, and I am careful with it. But I invested my time in studying. So, you know, alhamdulillah, I've got a decent job, decent pay, and I don't do heavy lifting. And at the moment, you can work. I know kids who works in Amazon, and they're making £12 an hour night shift. So they're making about £500 to £600 take-home pay. But that Amazon, it'll break you. It's only for 2 or 3 years, because my son did that part-time job at Amazon. They count every single second. Okay, so remember, delayed gratification. Work hard for the next 5 years, and inshallah, the rest of your 50 years will be much easier. Otherwise, go and work now in Amazon. Don't go college, don't go uni, and the rest of your 50 years, you'll be working in
the same job.
Same job. Yeah. So be mindful of that, please.
The other question it says is that although it costs the same as other degrees, but does it pay as much in professional jobs?
Well, with engineering, obviously we have minimum wage in this country, which at the moment is, I don't know, 18, 19 grand. But as an engineer, if you look up your starting salary, I have students who's gone to Nissan after graduating. Their salary is 29 grand. Starting salary is 29K.
29 grand, mashallah.
And 2 years later, it's 33 grand. And they can have a car as well, which is a reduced price. You know, if they work at Nissan. Same at Jaguar. So if you work at a decent company, your starting salary is in the 90s. I have a student from India who's on industrial placement. He's doing embedded systems. So he's from India, and he's got industrial placement as a company called PCL in London. It's a very small company, but he's getting paid 24 grand. Now, I mean, for an industrial placement person,
Getting 24
grand, oh man, you know, yeah, I would
a
be
lot of money.
getting that money. So for engineers, you can get anything from 20 to 25 to 30, 35. Okay,
Yeah.
but okay, money is important. We do this, we work for money. But I think initially for the first 10 of your years of your career, of your life, build your career in where you are, become a better person, good person, become an expert in what you are, and then work your way up. Money will always come. Success will always come. Be passionate in the subject area that you want to do, that you want to pursue. Success, inshallah, will always follow. Money will always follow. Respect will always follow. Because remember, at the end of the day, you know, we are the ummati of our Nabi as well. We represent Islam. We represent Deen as well, wherever we go. So that's there, and that's to be reflected in our nature. Because the Deen was not a majority. The Deen was spread mainly by our akhlaq. You know.
That is correct. Character.
How other people perceive. Praying salat and all that is okay, and it's important and it's for us. But how we are as a person, how they see us, and you, and as Brother Ali said, you know, our Nabi's teaching is that, you know, for knowledge travel as far as China as well. Okay, and we should be in every different environment, and we should be in every industry that we represent.
Thank you.
Okay.
Ali Bhai, anything to add on?
Yes, exactly. So basically, engineering is a very rewarding profession. So don't worry about money in this sector, I must say. Don't worry about money ever. It gives you, it returns you a lot more what one spends on it. So I can guarantee that, inshallah.
Inshallah.
And if you don't get that money, then take it from Ali as well. You know.
Yeah, okay, mashallah. It was a very useful sort of our webinar. I think both our speakers have contributed, and our participants have added a lot of questions and make it more interactive. So I think, inshallah, next year we will come back with a similar theme on this period of time. And inshallah, with feedback, we will make some improvements or other suggestions we will incorporate. So I will thank you to our both speakers and all the participants who join in our webinar. And inshallah, we will meet at some stage with the vote placements, other things in the same forum, inshallah. So jazakallah khair for everybody for attending.
Jazakallah,
much for
everyone.
listening.
Thank you for taking
Thanks
the
very
time.
much. Thanks very much.
Thank you then. Thank you. Bye-bye.